Hello, everyone, and welcome to another mini Sky Tonight. And happy Star Wars Day. After all, May the 4th be with you. So, I decided to do a topic that has kind of been near and dear to my heart because often when I do Sky Tonight presentations in the planetarium, many people bring their misconceptions from what they've seen in the entertainment industry, especially what they've seen in movies. So, I decided to talk about 3 different movies that I know of that have huge science plot holes. And I decided to go with older movies because I didn't want to spoil any new movies that have come out or soon to come out, because I don't like to give spoilers. So these movies have been out for quite a long while. So I will toss a spoiler warning. I'm going to cover over topics from 3 movies that have been out for a while. So if you haven't seen these movies, I recommend taking a moment to pause the video and go watch these videos. All right, so this topic for the presentation today is why Hollywood doesn't do science. Because the Hollywood industry is meant for entertainment. Their motto, as I often say, is fake it till you make it. They can throw all the big bangs, all the splendor to make it look fancy and pretty to entertain people, but sometimes those curves that they do in actual real science or in actual effects, sometimes it doesn't happen in real life. So let's go over 3 movies that have some, as I like to say, astronomy faux pas. And of course, in honor of Star Wars Day, the first one I have to cover over is Star Wars. To quote Han Solo about the Millennium Falcon, it's the ship that made the Kessel Run in less than 12 parsecs. I've outrun Imperial starships, not the local bulk cruisers, mind you. I'm talking about big Carillion ships now. Once you look at this quote, it kind of makes you think that a parsec is a unit of speed. It's actually not. Sadly, the scruffy looking nerf herder doesn't know what he's talking about. A parsec is a unit of distance. Now, to give Han Solo some credit, the speed of the Millennium Falcon is roughly around about 652 miles per hour when it's not in light speed. So he's got a pretty fast ship. In fact, there has been some debates between some of the fan base of whether or not it is the fastest ship in the Star Wars universe, but I'll leave that up to the comments for debate. But let's talk about his statement, 12 parsecs. Now, yes, people have tried to retcon this statement, but in the original book, it said units of space-time, which is kind of sad because he got the term wrong. So what is a parsec? Well, let's take a look. Before we talk about the term parsec, we need to talk about another term. It's called parallax. Now, parallax is the apparent shift of an object in the foreground, given the background, given between 2 particular positions of a different view. Believe it or not, you do parallax naturally with your eyes. Just to give you an example, you can do this right now. Take your thumb and stick it out in front of you. And I want you to close one of your eyes and cover an object with your thumb. And then switch your eyes. Notice your thumb is no longer covering that object. That's parallax. Your thumb is closer than the far object that you're looking at, so it looks like it shifts. And if you measure using a little bit of geometry of that shift, you can measure the distance between your thumb and your eyes, because you can figure out the distance between your 2 eyes. So therefore you can figure out the distance between your eyes and your thumb, which is really cool. And we use that technique daily because it helps us give our depth perception. Well, in astronomy, we take that technique much farther in a broader perspective. So as you can see in this image right here, we take 2 positions of the Earth in its orbit, like sometime in July versus sometime in December, and we measure the stars. And as you can notice in this example star, the star that we're looking at shifts with respect to its position. The star shifts with respect to its position given the background stars. So measuring the shift and the angle of that shift, we can figure out how far away it is. Now, where does parsec come in? Well, parsec literally stands for parallax angle of 1 arcsecond. Now, in the sky, astronomy, we don't measure distances by like this star is this X amount of meters from this one, because as we talked about in parallax, sometimes a star, even though they look really close in the sky, can be this far apart in real life, even though they're this close when we see them in the sky. So what we have to do is we do it measured in angles. So instead of we measured in degrees, but to break down degrees, we measure arc minutes, arc seconds, and so on. So we're talking about a tiny little smidge of an arc. So a parallax angle of 1 arcsecond is what we call a parsec. So that means, what does that mean in terms of distance? Well, its actual true distance is roughly about 3.26 light years, or about 10 trillion miles. So still a very long way. So to shift that tiny amount between two positions shows you the star has to be that far away. So now, Hans said he used it as a unit of speed. It's not a unit of speed, it's a distance. Now, yes, they tried to retcon this in the new movies with the new Solo, a Star Wars story movie, where they said that the distance between the Kessel Run is usually an 18 parsec route. Now the Kessel Run, just to kind of give you a bit of a history behind it, because they didn't quite explain it well in the Han Solo movie. This was a smuggler's run. The line that you can see down below here, this was the normal path that people had to go to in order to get to Kessel. Problem was, is it had tons of Imperial soldiers and star stops. And if you were a smuggler and you didn't want to get caught, you had to find an alternate route. So they found this route called the Kessel Run. This particular run was so tiny that most Imperial ships couldn't get through safely without accidentally hitting either an asteroid or running into a black hole, as you saw in the Han Solo movie. And so this 18 parsec route was some of the safest route to get to Kessel to kind of smuggle spice. Now Han did it in 12 parsecs. That's how they related it into retconning it. Rather than it being standard units of time, they did it in terms of standard units of distance, to where he shortened the distance of 18 parsecs to 12. Nice try, but we now know the truth that Han Solo really didn't know what he was talking about. So now you know. The next one I wanted to talk about is Tomb Raider, because I have so many people that have tossed me emails saying, oh, this planet's going to do this, and this other planet's going to do this. As a side note, remember, always look up your facts, because too often many people take what they see online or in a movie as face value, pure fact. It may not necessarily be true. For example, in the movie Tomb Raider, they said that every 5,000 years, the planets align. Now, most people definitely can agree with me that no planetary alignment can grant the power to anything. Like in this particular case of Tomb Raider, it granted the triangle the power to control time and space and everything in between. Now, yes, most people stop there, but people still believe to this day that planets can indeed perfectly align. And when you have scenes like this from the movie, it makes you kind of wonder, is it true? Again, Hollywood does what Hollywood does best. Fake it till you make it. And this is a fake shot. The planets never align that beautifully. Also, as a personal pet peeve, you never have your observatory in a house, because you have to have a telescope at the same kind of weather conditions and temperatures as the outside. So if it's in a house, it's basically the telescope is now at the temperature of inside the house and not what it is on the outside. So therefore you get a ton of heat waves plus radiant noise from inside the house and everything. So observatories are not great in houses. Hence why most observatories are often like the mountain ranges by themselves, far alone from civilization. Although, to be fair, having an observatory in your house, in my personal opinion, would be really, really cool. But nonetheless, back to the planetary alignment. So what do we mean by planetary alignment? Let's first take a look at the orbits. Now, the orbits of the planets aren't exactly in a line because they're slightly tilted, or the proper term for it is called orbital inclination. What I mean by orbital inclination is instead of it being just completely flat, it's slightly tilted. And you kind of can see in this image right here, like for example, this line right here, that's Pluto. It has the largest orbital inclination of 17 degrees. Whereas in most the other planets have an orbital inclination between 0.1 and 3 degrees. So they're not exactly perfectly flat on the same plane. So that means they will never be able to cross exactly in the same place. But usually when we talk about planetary alignments, what we talk about is called planetary conjunctions, to where it looks like in the sky that two planets are really close together, if not on top of each other. In fact, ancient people used these planetary conjunctions for signs and as well as information about the sky. In actuality, even though these two planets right here, like for example, this is Jupiter and Saturn, that you can see this planetary alignment sometime in December, or this planetary conjunction sometime in December. So sometime in December, you can see these two planets that look really, really close to one another. But if you look in through a telescope, so here's kind of like a view of a telescope, they do not overlap. Now it's still a really cool shot because you can see the two planets in the same field of view in an eyepiece, but they are definitely not in alignment, and they never will be. In fact, I think it wasn't until 1055 BC that all the planets, that there was at least 3 planets that were in the same field of view. So for this event to be happening every 5,000 years is a bit of a stretch. So planets do not align. They do conjunctions, which they look like they're close, but in actuality, they're not. So in fact, for you astrologers out there, I'm sorry, planetary alignments and everything don't happen and they don't affect your life whatsoever. Ladies and gentlemen, you are the masters of your own fate. Every day you have the power to do amazing things. Don't let the stars determine your fate. You have amazing capabilities. Carpe diem. Seize the day. Change what you can. Even in these crazy times right now that we're in, you can still do amazing things. All right, the next one is Armageddon. Oh boy, where to begin? Yeah, I'm pretty sure a bunch of you are cringing from after watching that movie myself because, oh boy. Yeah, this was a huge, huge mess up of a movie when it comes to science. In fact, instead of going into some of the nitpicky things I found bad with this movie, let's just talk about the premise as a whole. That there's going to be a huge asteroid that's going to impact the Earth, and that drillers from the United States are the ones that are going to break up the asteroid before it hits the Earth. Okay, let's break down this huge fiasco. First of all, asteroid versus meteor. They often threw out this term flippantly throughout the entire movie. An asteroid is an object mostly composed of like silicates and carbons and metals that exist outside between the orbits of Mars and Jupiter. And they can be anywhere between 33 feet to 329 miles in size. So these are big objects. A meteor, on the other hand, is an object that burns up in our atmosphere. We usually call them shooting stars or fireballs, and they can be anywhere from the size of a grain of sand to about 33 feet, give or take. So these are on the smaller end of things. Now this is a meteor, meaning it burns up in the atmosphere, and we see streaks across the sky. Now, for objects that are bigger than that, I think there are a few objects that have hit the Earth that have been definitely bigger than that, that have impacted the Earth. They're called meteorites. In fact, here's a little bit of here's a video of meteors that I was able to find that shows you roughly how often meteors and fireballs have occurred and how powerful they are. Most of the time, they're not that powerful. They're just a beautiful streak across the sky. But some of them have been indeed powerful enough to do a lot of damage. For example, the one that happened, and I apologize if I butcher this name, I do not do Russian very well, the Chelyabinsk meteor. This huge meteor that went across Russia didn't impact, but instead exploded roughly around about 18 miles above the surface because it became a pressure cooker where the metals on the outside were compressing inward as it was being heated up and compressed by the Earth's atmosphere, and the gas that was inside just all of a sudden caused it to pop before it even impacted. And that pop was huge. It was, they estimated to be the equivalent of 500,000 tons of TNT going off all at once. This was devastating. Fortunately, there were no deaths related to it, but several injuries because this huge explosion in the atmosphere literally leveled an entire forest. Like huge oak trees were completely grounded on the ground. And several cities that were nearby, the reason being why there were so many injuries is because people were hit by glass. They were in their homes when all of a sudden the shock wave that was created by this explosion in the atmosphere caused a huge shock wave that literally burst open windows. So it was pretty devastating, but fortunately, no deaths. A lot of injuries, but no deaths. And then of course, do like big events like this happen across our solar system? Yes. For example, in 1994, the comet Shoemaker-Levy number 9, which was about 3 miles in diameter before it got close to Jupiter, was broken apart into 21 pieces. And those 21 pieces impacted Jupiter. In fact, the biggest explosion that hit Jupiter was roughly 600 times more powerful than all the nuclear explosives in the world combined. So if you took the whole world's nuclear arsenal and blew it up all at once, the one impact from Comet Shoemaker-Levy number 9 on Jupiter was still much more powerful. Crazy, right? So these kind of events can and do occur, but they're not on the same level as what they are predicting in the movie. They're rare. So fortunately, we got several things that are going good for us. In fact, we have seen the scars of major impacts. For example, Meteor Crater in Arizona is roughly around about 50 meters across, and it was 150 times more powerful than the nuclear bomb that went off over Hiroshima. And they believe that the original meteor was about 50 meters across, and and the crater itself is about 100 kilometers, and it's 750 feet deep. So, do big impacts happen on Earth? Yes. But fortunately, this particular impact at Meteor Crater was over 50,000 years ago. So nobody was around. We're good. And also, as you can see right here, even big impacts like the one that happened on Jupiter left some scars behind too. But fortunately, Jupiter's atmosphere blew off most of the scars away. Fortunately, we have a lot of things that can help us to prevent these kind of disastrous events now today. For example, the Catalina Sky Survey basically takes pictures of huge sections of the sky and tracks anything that moves. In fact, it is their job to look at near-Earth orbit objects. Skyscan is also another one where they do a survey of the entire scan. NASA has several projects that they have working, including what is called ATLAS, the Asteroid Terrestrial Impact Last Alert System. And of course, when I talk about NASA, there is an actual position for preventing these tragic events. It's literally called the NASA Planetary Defense Officer. So you thought Space Force was a thing? Well, NASA did it better. They actually have somebody who it's their job to look at this. Yes, it's an actual real position. And in fact, I took this from NASA's website. So it's their job to look at near Earth objects and to track them and to look at different plans of what we can do to prevent a disastrous event. Now that we have that kind of idea of what these events can be like, let's now look at the movie. First of all, take a look at the meteor that comes from the movie. That does not look like an asteroid. As I mentioned, asteroids are mostly made of carbonate and silicates. They do not have like this hue that goes around them. That's comets. So they got that one right. They got that one part wrong. And they also quoted that the size of this asteroid was roughly about 14,000 kilometers, or the size of Texas. The biggest asteroid in the solar system is 900 kilometers, and that's the dwarf planet Ceres. Nice try. Also, most meteors that big, we wouldn't discover them just that far late, because in the movie they only had about 14 days to save the world. If it was something that big coming close to us, we would have noticed it. Also, why is it that always, every time when the big huge crater or big huge asteroid or big huge comet breaks up into little pieces and those fragments hit the Earth, they always hit big cities and everybody's panicking? Like, for example, you see this scene from New York where everybody's like in a huge panic down in downtown Manhattan. What about the people of upstate New York? Now, granted, Hollywood probably wouldn't find big footage of people panicking out in the middle of a field somewhere, but it's always big cities in Hollywood. Also, as a fun little fact, just to show you how bogus this movie was, one of the scenes, as I pointed out right here, on the meteor, that's grass. For something that's supposedly supposed to be so deadly and lives out in the corners of space where it's absolutely frozen, there's grass. So, like I said, Hollywood does what Hollywood does best. You fake it till you make it. And besides, their plan in the movie was to take drillers and send them to an asteroid to break it apart. We wouldn't hire people just off of the blue. We would actually train people. And believe it or not, we do have a better plan. There's an actual plan, and this is literally a documentation from the United States itself about what to do in terms of near-Earth object preparedness and strategy action plan. It's an actual government document. In fact, if you Google this on the website, Google this and Google it and everything, you can find this document and read it for yourself. We do have better plans. And even today, scientists and astronomers are coming up with different ideas of what to do. So these are just 3 movies I wanted to debunk and to point out, look, Hollywood loves to throw out action and science facts to make it look really cool and interesting, but in actuality, they sometimes throw around facts that are not necessarily true. So be sure to scrutinize things before you take them as face value. If you liked this video and some of the movies I've covered thus far, leave a comment down below. And if there's any other movies you would like for me to try to cover over, I'd be more than happy to. Just make your suggestion down below. If there's any topics you would like for me to cover over in future Sky to Night presentations, let me know as well. And until next time, stay safe, stay healthy, and as always, never stop learning.